Hello everyone! Thanks for joining me in the Allan Block workshop to learn about one of the best design tools in the industry. What I will be showing you in this video is the Plan View input screen from within AB Walls. Today, I will be entering data from an example project manually, but the Plan View can also be imported using AB CAD or our built-in import function. For more information on these functions, please watch the corresponding videos covering these topics. Let me share my screen with you to show you how you can do this. The layout of this screen resembles the elevation worksheet, grid lines displayed above and coordinate boxes below. While a plan view is not mandatory for a complete design, it will provide the wall layout from the top-down view, along with the geogrid length displayed behind the wall, creating a more comprehensive set of plans at the project's conclusion. To input values, I will extract the coordinates from the example project. The screen features an x-axis and a y-axis, where the different points are already scaled. In our example project, the starting point of the wall will be at x equals 0 and y equals 62. The next location will be at x equals 70 and y equals 9. Once these points are entered, clicking the Draw Plan button will generate a blue line segment representing the wall. I'll now proceed to enter the remaining points to complete the plan view of the wall. If you prefer to view the entire wall at once, you can click the crosshair button at the bottom. One thing to note is that mitered corners are weak points in the wall due to the vertical seam at those locations. Not only are these seams weak, but they also increase labor costs for contractors. When encountering a non-90-degree corner, we recommend using a radius curve instead. To add a radius curve, I'll utilize the Add Radius button located at the bottom. By default, it uses the value provided in the adjacent text box. I will use a radius of 20 feet and click the Add Radius button. A box will appear, allowing me to add a radius to point 1 on the screen, and in the coordinate boxes below the wall, you will notice that point 1 has been split into 1A and 1B. These represent the start and end of the curve, indicating where the wall should begin and end the radius. This method provides a convenient way to input a radius by splitting a specific point in two. Clockwise and counterclockwise buttons will appear, allowing me to adjust the concavity of the curve in either direction. To revert to a mitered corner, I can simply click the Undo button, which will take you back to the previous mitered corner state. Alternatively, instead of splitting a point, I can create a curved line segment between 2 points. To achieve this, I will enter an assumed radius in the blue box for the desired starting point of the curve. Initially, the displayed radius may not appear correct, but through trial and error, we found that a 40-foot radius fits our layout. Lastly, I will compare the elevation lengths to the running distance, ensuring that both screens align as closely as possible. Once this check is complete, I am now ready to move on to the next page. The Plan View input screen is a useful tool in the AB Walls toolbox. Adding a plan view to your project allows you to export your project to a 3D model and will enable the option to select the plan view to be used for the project estimate worksheet. When using the plan view in the estimate, it adjusts for a reduction in blocks required for outside curves and increases quantities for inside curves, giving you a more accurate estimate. It will also add a site plan view to your output, making a more complete, well-rounded project. For additional videos, please visit us at allanblock.com. Always better, always Allan Block.